On this video, I'm going to be introducing the idea of negative externalities, covering some evaluative points. I'm going to be using a non-standard example. So let's take an example of driving into work. Now here, I'm assuming that the only thing we're interested in is how long it takes to drive into work, so time is the only resource. Now, driving into work for me, say in the middle of the night in August, it takes about 15 minutes to drive in. There are virtually no other cars on the road. When I normally start work, which is in August when the GCSE results come out, there's cars on the road. There's about, say, 50 cars on the road, and it still takes 15 minutes. Why? Because I'm not holding up other drivers. The roads can easily accommodate 50 cars. There's going to be 50 cars on the road because people ain't going to be taking their kids into school, and a number of workers are going to be on holiday, so they're not going to be holding me or other people up. Now, a couple of weeks into term, it reaches about 25 minutes because those other commuters and people driving their kids in are going to be on the road at that time. So when there's 200 cars on the road, it does become rival, and they're going to start to hold me up. So let's steam in with the definition. Private cost is the cost to the individual or firm of an additional unit of output. So in this particular case, it's going to be how long it takes the driver to get to work. Now you can see the initial data on a graph here. So the marginal private cost between 0 and 50 cars being on the road, it takes 15 minutes, and then gradually it increases because those other cars are slowing up the driver, up to a total of 25 minutes. So the question is, does it make sense both for the individual and for society for someone to be using the car for those first 50 cars? Well, the opportunity cost of driving would be going in by tube. Now that takes 30 minutes. So for those first 50 cars, well, definitely for the individual, because it's only taking them 15 minutes to get to work rather than 30 minutes. So the first party is happy. Now, if there was such a thing as a lord of economic resources, which there should be, they're also happy because it's only taking up 15 minutes of society's time rather than 30 minutes. So everyone is happy. And that's being shown by these wonderful happy faces on this graph. So let's add to our definitions. The external cost is the negative impact to a third party. In other words, someone other than the people taking part in the transaction. In this case, it's the driver making the decision to drive to work, who are going to be negatively impacted by that decision. So the total cost, or the social cost, the cost to society, is made up both to the cost to the individual who's made the decision and others who are affected by that decision. Well, when there's up to 50 cars on the road, no car is throwing up any other car. There's enough space for all the cars. So the external cost is zero. So the marginal private cost is identical to the marginal social cost. But beyond that, you get a certain amount of rivalry. Let's assume that while we are on the road, we are adding 4 seconds to other drivers' journey time. So they are holding us up, but we are also holding them up. So what's the external cost when there are 200 cars on the road? Well, 50 of those are effectively free. We're not holding them up at all. But for each of the other 150, we are adding 4 seconds to their journey time. 150 times 4 is 600 seconds. So the external cost is 600 seconds or 10 minutes. So the social cost, well, the private cost is 25 minutes. That's the time it's taking us to drive to work. But we are also adding 10 minutes to other people's journey times. So with 200 cars, the social cost is 35 minutes. So on the graph, we now need to add the marginal social cost. Now for the first 50 cars, there's absolutely no difference between the marginal social cost and the marginal private cost because there's no rivalry on the road. But beyond that, the total cost, the social cost, is increasingly moving away from that marginal private cost line because everyone is snarling everyone else up. You'll note that we can identify the external cost by the vertical difference between the two lines. You'll also notice that at 162 cars, the social cost actually moves above how long it would take us to go in by tube. We're coming back to that later. So again, is this a good use of resources? Well, obviously, even if there are 200 cars on the road, the first party is happy because they're taking 25 minutes to drive into work rather than the 30 minutes that it would take them to get in by tube. Obviously, they're happy because they are making the decision. If they weren't happy, they'd go in by tube. Now, up to 162 cars, the Lord of Economic Resources is also happy because the total social cost is still less than the 30 minutes that it would take to get in by tube. However, beyond 162 cars, that Lord of Economic Resources is getting pretty cross because the total social cost, the marginal social cost, is above the time that it would take had that person decided to go in by tube. Now, unfortunately, because there's no such thing in reality as the Lord of Economic Resources, he can't smite the driver down. So the first party will still choose to drive to work because it makes sense for them to do that. Even if, you know, right up to taking 30 minutes to drive to work, that's still better than going in by tube. So what we are saying there is that the free market will produce beyond what the Lord of Economic Resources would want. To put it another way, they produce beyond what society would want. So the diagram shows that for the first 50 cars, both sides very, very, very happy. To put it another way, society is happy and the individual is happy. Up to 162 cars, both sides are happy. But as we move beyond 162 cars, though the private individual is happy because they're still saving time if they go in their car, society is not happy. So ideally, we should be producing up to 162 cars. So if there's, say, 165 cars on the road, from society's perspective, that individual should go in by tube. But they're not going to go in by tube because they personally save time by going in their car. Now, even on this silly example, we can get some evaluation. And the first one is that we need to turn that time into money. Normally, when we draw a diagram in economics, that y-axis is labeled price or revenue and cost or whatever you want to label it. This is not labeled time. So we need some means of converting time into money, which implies some questions. Well, first of all, is everyone's time valued at exactly the same? Well, you can see there I've got 4 examples. I've got a pensioner driving. They've got loads of time when they can drive. I've got an ambulance. Now, if we are holding up an ambulance by 4 seconds, that could be costing someone their life. We've got a commuter. They are trying to get to work. Or we've got a leisure traveller. So all of those individuals, their time would be valued in a different way. But yet I'm showing it on one line on a graph to see if time matters. Now, secondly, what did I say? I said, well, if I go into work, say in August, there's going to be 50 cars on the road. Well, how on earth do I know that? Have I measured them? No. When I go in at other times, are there really 200 cars? So there are questions about measuring even the quantities. So in the case, say, of air pollution, how much air pollution is being pumped up into the atmosphere? And then we have to convert that into an actual sum of money. It's actually virtually impossible to do it, not just difficult, it's virtually impossible, particularly as a lot of those effects will actually take place in the future. So it may well be that there's pollution going up into the air now, perhaps by people using spray deodorants or whatever, and that is causing holes in the ozone layer, and that is causing skin cancers for people hundreds of miles away. Well, they're still economic agents, but it's really difficult to actually measure that. Similarly, things like noise pollution. Aircraft create noise that could have a negative impact on people, but we've got to actually turn that into money. Really difficult both to measure it and to turn it into a sum of money. And finally, we've got that other things being equal point. So if you can think of other externalities, either negative or positive, in the case of cars, the obvious one will be traffic pollution. It could be air pollution, it could be noise pollution, it could just be the fact that people don't like seeing queues of traffic doing nothing. Then that would make that argument even stronger about the negative externality. Or alternatively, if we can think of an external benefit to offset the external cost, in the case, say, of aircraft, tourism is going to be an external benefit to offset the cost of air pollution and noise pollution, then again that gives us our paragraph that starts however, which is a decent way of getting evaluative marks. And that finishes this video. Thank you.